Hello friends, this video is part of video tutorials dedicated to learning Microsoft Fabric. In the last few lessons, we learned navigating Lakehouse and using Spark notebooks. If you have watched my earlier videos on data pipelines and the data flows, you may remember that we brought data to Lakehouse without even worrying about creating target tables, which is probably easiest way to get started. However, this may not be quite desirable method if you are dealing with many hundreds of tables. So creating tables programmatically is a more preferred and scalable way of doing that. It also ensures that your data types are what you wanted them to be. Follow me on to learn more about that. Hello friends, welcome to my channel. My name is Fikrat and today we are learning to manage tables in Lakehouse. Here's a quick preview of topics to be discussed. We'll start with table creation options where we'll first explore PySpark ways of creating table. So we'll explore two methods available in PySpark. Then we'll move on to a couple of methods available within SparkSQL. So we'll use how to use it, simple create statement, and we'll then learn how to use CTAS syntax within SparkSQL. Then we'll move on to another method. It's probably easiest way. That's called auto discovery, which allows you create tables even without coding. Next, we're going to learn how to remove tables. And then we'll discuss what are the different types of tables. So what are the managed table versus external tables? What are the differences what are the differences between these tables when you are talking about table removal? If you are new to the channel, please take a moment and subscribe to be always up to date with my videos. Let's jump into the demo. All right, I am in Microsoft Fabric's homepage and I have selected Data Engineering Service. For the purpose of today's demo, I'm going to use multiple artifacts. Most of the work will be done in Notebook that I'm going to share link for in my video description, and you can use Import Notebook button to bring it to your environment. Then it's desirable to have OneLake Explorer in your machine. If you don't know how to install it, please watch my latest video on that. And finally, we'll need to have Lakehouse. So this is a Lakehouse that I already created. I will navigate to that. And from here, under Files folder, I created CSV subfolder. I'm gonna upload CSV file from my local machine to that folder. I'll click three dots, select upload and select upload files, and I'll navigate to the folder and bring the file. I'll share the link for this file in the video description as well. Okay, now let's open the notebook. So I'll navigate to open notebook and use existing notebook link, and we'll select my notebook. The first two methods that I am using to create Deltalake tables in the notebook are relying on PySpark data frames. So my first cell creates PySpark data frame from CSV file. This is something that I have auto-generated, so you can do that by navigating to the file and using load data and selecting Spark. And here I replaced absolute path with relative path. So in case you don't know how to do that, you can click here and then get relative path from here. Beginning of this command is common for all types of reads, so it just contains a spark.read, and then I am specifying CSV um, as a format, and then I say my file also contains column headers, and finally I specify the okay, so the first method is using save as table method. So it starts with data frame, and then I'm using write method, and I'm specifying format, which is going to be delta, and I say it's going to use overwrite method, which I'm going to explain shortly. And then this is the main method where I say save as table, and I provide table name here. So let me run this first two statement here. Okay, so if I refresh my tables, I'll see the table underneath. One thing to note here is that this command not only creates a table, but also populates the table with the data from data frame. Okay, so the next method is similar, except it's using save method. So as you can see with save method, I am specifying table name as well. Uh, However, what's different here is that I am also specifying folders here. So this command is a little more flexible. It allows you create tables based on files, which will be either in tables or files sections. If you want you base your files in table sections, then you provide tables folder. Otherwise, you provide files folder. Let me run this command as well. Okay, so the next method is relying on SparkSQL. As you can see, I am using SQL magic here. And the next part is create statement. So my create statement includes column information, so column names and types. And at the end of this, I am specifying the tables. So the tables can be different types. So in this case, I am telling create delta tables. The next method that I'm going to demonstrate here is also based on Spark SQL approach. However, it's using slightly different syntax called CTAS, or create table as a select syntax, which is well known in SQL world. So as you can see, the command starts same way as for others create statement. However, here at the end, I am saying bring the data from another table. And another difference is that we don't have columns section here with this syntax. So let me run this statement as well. Let me bring a couple of comments related to Spark SQL way of creating tables. First, you can use combination of Spark SQL and the PySpark if you are Python fan. So in this example, I am including this create table statement as a string, here command string, and I am calling Spark SQL command to call this. which will lead to the same result. And then another thing to notice here is that I am using create or replace syntax here, although it's not mandatory. So I can remove or replace section, so this section from my statement, and it will still be valid. However, it will error out if you run this statement while your table is still there. So for that reason, it's recommended to include this. If the table is there, it will just recreate that. Now that we know how to create tables, let's see how we can remove the tables. I'm going to navigate to my notebook. I think the easiest way to remove tables is to use SparkSQL syntax. So if I scroll down and under manage tables, we have this command, which is very straightforward. So all you need to specify is table name. And if I run this statement, that will clean my table. So if I refresh my table sections, this table is no longer there. Now, you might be asking, what happens to the data and the log files when you remove the table? So the answer depends. So the tables that we have been creating so far are considered managed tables. So if I scroll up, uh, you may notice that we didn't specify locations for these tables, which means that Spark will create them in a root folder, in a default folder, subfolder under root folder. And that also means that when you remove these tables, the Spark will clean up all these underlying files, which is convenient options. However, in some cases, you might prefer to keep the table files, underlying files, when you remove the tables. For that case, you might use different table creation option, which I'm going to show here. So if I scroll down, so this command is similar to what we have used previously, except you can see that we are using location statement, and we are directly telling where the underlying files should be. So in this case, we should specify somewhere, some location on the files folder. And I have created Delta tables subfolder here, and I say create this all the files under this subfolder, contacts X subfolder. So let me run this. So the Spark will create unmanaged tables. It's also called external tables. Uh, so from Lakehouse Explorer perspective, they will look very similar. Let me insert some data inside. And if I navigate to the folder where we have based this table in, so in Lakehouse, I will go to Files, and I will refresh my on Lake. So now you can see that it created this folder, and we have all the data and the log files. So let me go back to Fabric and run this drop statement. And if I navigate to my Lakehouse, explore, and refresh this folder, as you can see, my folder still there, even though in Lakehouse Explorer, this table is no longer there. Okay, so that also means that if I recreate this table on the same location, I should be able to see my data. So I'll recreate this table, and if I run this select statement, sure enough, we have all the data inside this table. Now, you may ask, are delta tables are the only table types that can be created in Lakehouse? And the answer is no. So if I scroll down, the last cell in my notebook contains create table command, which is using CSV format, as you can see here, and it's pointing to the location where I have CSV files. So if I can run this, and then I can select this, so I can select from this table, and this will bring me data. So let me refresh my table list and zoom in my Lakehouse Explorer here. So the tables that we created using Delta format have slightly different icons than tables that are on CSV. This concludes today's discussion. So to summarize, we have learned several ways of creating tables in your Lakehouse. Some of them rely on SparkSQL, whereas some of them are based on PySpark. Uh, Selecting language, it comes to your preference. If you're coming from SQL world, you'll probably use SparkSQL. And otherwise, you may choose PySpark, R, Scala, or some other available languages. Please feel free to post your questions. I will be happy to answer them. Thanks for watching, and I will see you in future videos.